Set is defined as collection of well-defined objects. The meaning of well-defined objects is, let us take one example, 2, 4, 6, 8, 10. All these are called as even numbers. So, these are the numbers of well-defined property called even numbers. Take one more example, 1, 3, 5, 7, 9. These are all the well-defined numbers of odd number property. So, this is called as a set. A is equal to set of. The set will be denoted by the symbol flower brackets. Now in this set we have 1, 2, 3, 4 numbers, but in sets chapter we will call these numbers as elements. So how many elements are there? 1, 2, 3, 4. So number of elements present in A set is 4. Now take let us second example. B is equal to set of 5, 6, 7, 8, 9. So these are all called the elements. Number of elements present in B set is total 5. So overall the elements which are present in that particular set, we can count it as number of elements. We have three types of sets: finite set, infinite set and empty set. Finite set means you should able to identify first element and last element. In this set, A is equal to set of 1, 2, 3, 4. We have 4 elements. In this first element is 1, last element is 4. We are able to identify both first and last. So this is called finite set. Let us take second one as infinite set. Take B is equal to set of 5, 6, 7, 8, 9, so on. In this, we are able to identify only the first element, that is 5. We are unable to identify the last element. So this is called infinite set. Third one is empty set. In empty set, we don't have any elements. Then that set is called empty set. Now we are going to start operations on sets. So first operation is union. Union is nothing but combination of both the elements of sets. Let us take the example. A is equal to set of 1, 2, 3. B is equal to set of 4, 5, 6. A union is the word. We will indicate the symbol by the letter U. So A union B is equal to, A set is 1, 2, 3. Again union word will denote with the symbol U. 4, 5, 6. Union means combination. So first what elements are there in the A set, as it is we will write 1, 2, 3. Next B set elements are 4, 5, 6. So let us continue 4, 5, 6. So A union B is a set of combination of A set elements and B set elements. Now second one is intersection, the elements which are present in both the sets. Let us take example. A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6. Both means here 3 is present in A set and 3 is present in B set. So we will get in A intersection B 3. And here 4 is present in A set and 4 is present in B set. So A intersection B is the elements which are present in both. The next one is difference. The elements which are present in only in the first set. A is equal to 1, 2, 3, 4, 5. B is equal to 4, 5, 6. So difference is the symbol we will denote with the letter, denote with the symbol minus. 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. 4, 4 will get cancelled because they are present in both. 5, 5 will get cancelled. So the elements which are remaining in only the first set, 1, 2, 3. So in difference A minus B, the elements are 1, 2, 3. Now we will start the properties of sets. First one is union. A union B is equal to B union A. Let us take example. A is equal to set of A, B, C, D, E. B is equal to set of C, D, E, F. First A union B, A set elements, union is denoted with the letter U, B set elements. I already said union means is a combination of both the sets. So first, right, which set is there here? A. So write all the A set elements A, B, C, D, E. And next B set elements C, D, E already we have written here. So repetitions are not allowed. So left out element is F. So A union B is A, B, C, D, E, F. Next one B union A. B set elements are C, D, F. A set elements are A, B, C, D, E. Here also B is the first set. So first write all the elements of B. C, D, E, F. A set elements A, B. Already we have written C, D, E. Repetitions are not allowed. When we observe first equation and second equation, both are equal. So here A is the starting element, C is the starting element. But even though the total number of elements of A union B is 6, B union A is also 6. So therefore our union property is verified. A union B is equal to B union A. This is also called commutative property of union. Let us see in the Venn diagram. A and B are the two sets. When we represent in the circles, two circles will intersect. This is called intersection area. In A and B, C, D, E are the intersection elements. So we have written in the intersection part. In A set, the left out elements are A comma B. So we will write it in the AB. And in B set, F is the element. So we need to write it here. So when we are asking to shade A union B, you need to shade completely whole set. Now similarly B and A also. First write the common element C, D, E. Enter in the intersection area. In B set the balance element is F. In A set the balance element is AB. So we need to shade. When we observe Venn diagram also, A union B is also same, B union A is also same. So this is called union commutative property. Now second property is intersection, commutative of intersection. A intersection B is equal to B intersection A. So let us take example 1, 2, 3, 4 in A set, 2, 3, 4, 5 in B set. A intersection B, as I already said, intersection is nothing but common elements. In A set 1, 2, 3, 4 is common. In B set also 2, 3, 4 is common. So in A intersection B, 2, 3, 4 is the elements. Now B intersection A. In B set also 5, 2, 3, 4 and in A set 1, 2, 3, 4. In these two sets the common elements are 2, 3, 4. Therefore A intersection B is equal to B intersection A, which is a commutative property of intersection. Let us see the Venn diagram of A intersection B. So this is the called intersection region. So A intersection B is already known as common 2, 3, 4. So let us enter the values of 2, 3, 4 in the intersection region. And in A set the balance element is 1. So we need to enter here. And in B set the balance element is 5. So we need to enter here. Since it is intersection Venn diagram, we need to shade only the intersection part. Similarly B intersection A. The intersection elements are 2, 3, 4. In B set 5 is the element here and in A set the balance element is 1. Since it is intersection, we need to shade only the intersection region. So this is called the intersection commutative property. Next property is associative property. In associative we need three sets A, B and C. So in associative first property is union. A union B union C is equal to A union B union C. When we are pronouncing also A union B is in the brackets. So we need to read as A union B union C is equal to A union B union C. Now let us take example A equal to 1, 2, 3, B equal to 2, 3, 4, C equal to 3, 4, 5. So first A union B union C. A union B, you need to combine all the elements of A and B. Repetitions are not allowed. A set 1, 2, 3. In B set 2, 3 already we have entered. So balance element 4. Union C set is 3, 4, 5. So union is a combination of both the sets. So first A union B elements we will write it in the answer. 1, 2, 3, 4. Already 3 and 4 we entered here. So the left out element is 5. So this is first equation. Now A union B union C. So A set is 1, 2, 3 union of B union C. Let us see B set is 2, 3, 4. So 2, 3, 4. In C set also 3, 4 already we have written here. So since repetitions are not allowed, so C set balance element is 5. Again we need to combine these two set elements. 1, 2, 3, 4, 5. Let it be second equation. Hence first and second equations are equal. Our associative property of union is verified. So now let us see the associative property through Venn diagram. Since in associative we have three sets, A, B and C circles will be there, and three C circles will have common intersection region is here. So in all the three sets we find 3 is the common element. So we have written 3 common element in the intersection part of all the three circles here. Now A and B. In A and B 2 is a common element, so we have written here. In B and C, we have the common element called 4, we have written here. So the left out element of A set is 1, so we have written here. Since B set elements all the 3 are accompanied here, so we no need to write any element in the B set. Now C set balance element is 5, we need to enter here. Since it is union, we need to shade all the portions of the Venn diagram. Similarly, A union of B union C. The entering the values of both the Venn diagrams are same. So once again, since all the three sets are having common element, 3 will be entered here. A and B common element is 2. B and C common element is 4. Since B element does not have any element, no need to enter anything here. In A set left out element is 1. So we have entered here. The left out element is 5. Since it is union, we need to shade all the portions of the Venn diagram. When we compare the answer and the Venn diagram, both are verified. Hence, this is the associative property of union. So, the next property of associative is intersection. A intersection B intersection C equal to A intersection B intersection C. Let us take example. A is equal to ABC elements, B is equal to BCD, C is equal to CDE. So A intersection B intersection C. In A and B, B and C are the elements common. So we have written here A intersection B means B comma C. Intersection C set elements are CDE. Now in this set and this set, C is the only element common. So we have written C. Let it be equation 1. Now take A intersection B intersection C. A set is ABC elements, intersection. In B and C, C comma D are common. Now in these two, C is the element is common. Let it be equation 2. When we compare both the equations are having the same set element C. Therefore, associative property of intersection is verified. So, let us see the associative property of intersection through Venn diagram. Since we already know associative property will have three sets A, B and C. Now in all the three sets C is a common element. So this is the area which we have to write all the three sets common element. Since C is the element, I have written here C. Now A and B comma C is a common element. Already I have entered C here. So B is the only element I can enter in the region A intersection B. B intersection C also, C comma D are the common elements. But already since C I have entered here, in B intersection C common element is D. In A and C set we don't have any common elements, so no element will be entered here. So we need to find which is a common element in all the three is C. So we need to shade this region here. Similarly the other side, A intersection of B intersection C. Entry in the Venn diagram is same. So in all the three set elements C is the common. A and B common element is B. B and C common element is D. Since we have associative property of intersection, we need to shade the region of C only. Hence both the intersection property of associative is verified through calculation and Venn diagram. The next property is distributive property. In this also we have two types, union over intersection. In exam, instead of learning the property, learn according to the words union over intersection. Since union is the first word, A union, over indicates brackets, intersection means B intersection C is equal to, when we are learning the property, multiply this A union to B. A union into B is A union B. Next intersection symbol here, A union into C is A union C. So the distributive property union over intersection. Union word is there first means A union over means brackets B intersection C is equal to A union into B is A union B. Intersection A union into C is A union C. Let us take the example K equal to 3579, L equal to 589, M equal to 1239. Now let us take, instead of A, B, C, we have used the letters K, L, M. So K union over means brackets, L intersection M. First the brackets part we need to solve. L intersection M. Intersection means common element. In 589 and 1239, 9 is a common element. So in L intersection M place, we need to write the element 9. K set is 3579. So union means all the elements. So 3579, let it be equation 1. Now we need to prove K union L intersection K union M. K and L sets we need to combine. Union means all the elements. So K union L values are 3, 5, 7, 8, 9. K union M is 1, 2, 3, 5, 7, 9. Intersection means we need to write only the common elements 3, 5, 7, 9. Let it be equation 2. Let us now see, compare first equation and second equation. Since both are equal, union over intersection property is verified through calculation. Now let us see the Venn diagram. Now since it is distributive property, we use 3 sets K, L, M. These are the 3 circles and this is the intersection part of all the 3 circles. In K, L, M sets, we have 9 is the common element. So we need to enter 9 here. K and L sets common element is 5. K and M common element is 3. In L and M we don't have any common elements, so we need not write anything. In K set we have total elements 3, 5, 7, 9. Since 3, 5, 9 we already entered here, the left out element is 7. Same way in L set we have the elements 5, 9, 3, 7. Since already entered here, 8 is the balance element, we need to enter here. And in M set the left out element is 1, 2. Since our property is K union L intersection M. First of all, L and M intersection region is this. So we need to shade first this. Then K union, completely K circle. So now our Venn diagram represent K completely circled and L intersection M. So this is the shaded portion of K union of L intersection M. Same way, this is the Venn diagram of K union L intersection K union M. Since therefore both the Venn diagrams are equal, hence our distributive property union over intersection is verified through Venn diagram and calculation. So in distributive, second type of property is intersection over union. In exam if they give intersection over union, A first word is intersection, so intersection symbol, over indicates brackets B union C, A intersection B, how to remember is A intersection into B is A intersection B, union, A intersection into C is A intersection C. Let us take the example K equal to set of x, y, z, comma t, L is equal to y and z, M equal to r, s, t. Now K intersection L union M. K set as it is, we will write x, y, z, t intersection L and M. Since union is the symbol, we need to write all the elements. So y, z, r, s, t. When we are finally finding the value K intersection, this value, intersection is nothing but common. In these two sets, we have the common elements y, z, t. Let it be equation 1. Now K intersection L. In K and L, we have the common elements y, z. In K intersection M, in K and M we have the common element T. Again we need to combine these both the values by the operation union. Union indicates all or combination of both the elements. So y, z, t, let it be equation 2. When we see first and second equations, both the answers are same. Hence intersection over union property is verified. Now let us see this example through Venn diagram. Since this is distributive property intersection over union, we use three sets, so K, L and M. So when we observe K and L, common elements are Y comma Z. So this is the region where we need to write K intersection L. And K intersection M, common element is T. Hence we don't have any common element in all the three sets. No value should be entered here. This is the region where we need to enter L and M common elements. Since we don't have any common, we no need to enter any value. So K intersection of K union L intersection K union M Venn diagram is this. K and L common elements are Y and Z, so we need to enter in this region. K and M common element is T, so we need to enter in this region. Since we need to combine both these Venn diagrams, we will get K intersection L union M this is the shaded region where both the Venn diagrams are same. So therefore, distributive property intersection over union is verified through calculation as well as Venn diagram. Hence distributive property is verified. Now the next property is DeMorgan's laws. This is the first law, A union B whole complement. Whole indicates brackets, complement is equal to A into complement is A complement, union opposite is intersection, B into complement is B complement. You need to remember the formula in such a way, A union B whole complement equal to A into complement is A complement, union opposite is intersection, B into complement is B complement. Let us verify this property by using example A equal to 2, 4, B equal to 3, 4, 5 and U is a universal set. This is the main set. These two are the subsets. We can write from this set the subset. These are the numbers present in the universal set 1, 2, 3, 4, 5. Now let us write the DeMorgan's law, first law. First we need to prove A union B whole complement. Complement indicates U minus of whatever is there in the brackets we need to write U minus of A union B. U set is 1, 2, 3, 4, 5 minus A union B is, in A and B we need to write all the elements because U indicates union. So we combine both the elements, we will get 2, 3, 4, 5. I already explained you about the difference. First we need to cancel the common elements and we need to write the balance element in the first set. Since one is the element is balance here, we will write, let it be equation 1. Now we need to calculate A complement. Whenever we see complement, we need to write U minus whatever set they have given here A. Now U set is 1, 2, 3, 4, 5 minus A set is 2, 3, 4. Cancel the common elements 2, 3, 4. In A set the balance elements are 1 and 5. Same way we need to calculate B complement. Complement means U minus, since B is the set here, you will write U minus B. U set is 1, 2, 3, 4, 5 minus B set is 3, 4, 5. Both will get cancelled 1, 2. A complement intersection B complement. A complement value we got 1, 5. B complement value is 1, 2. A complement intersection B complement. In these two, which element is common? 1 is the common. So we have written here 1, let it be equation 2. Now let us compare equation 1 and equation 2. Both the answers are same. So therefore, DeMorgan's law, first law is verified through calculation. So now let us see this DeMorgan's first law through Venn diagram. First we need to calculate A union B Venn diagram. A and B are two sets, so we have drawn two circles. In A and B common element is 4, we need to write here. And in A set the left out element is 2. And in B set the left out element is 3 and 5. U is a universal set, we will write it in the outside the circle, we will denote with the letter U. In that the balance element is 1. And A union B whole complement, we need to shade the region which is the outer region. Not the two circles, the outer region where universal set one element will lies. Now A complement, the entering the values is same. If it is A complement, other than the A circle, rest all the parts of the circle should be shaded including the B. If it is B complement, B circle only we will not shade, rest all we will shade. A union B, A intersection B complement is the outer region only we need to shade, where U universal set will lies the element 1. Since here DeMorgan's law's Venn diagram is verified, therefore DeMorgan's first law is verified through calculation and Venn diagram. Therefore, De Morgan's first law is verified. So now let us see De Morgan's second law. A intersection B whole complement equal to A complement union B complement. Here also we will read the formula. A into complement is A complement, intersection opposite is union, B into complement is B complement. Let us prove this law according to this example. U is a universal set 1, 2, 3, 4, 5. A equal to 2, 4, B equal to 3, 4, 5. So now let us prove A intersection B whole complement. Complement indicates U minus. Whatever is there given the set, the same thing, A intersection B. In A and B, 4 is the common element. So we need to write in A intersection B place 4. 4, 4 will get cancelled. The left out elements in the first set are 1, 2, 3, 5. Let it be equation 1. Now find A complement. Complement means U minus. Given set is A. So U set minus A set. In A set 2, 4 is there. Cancel 2, 4 in U set. The balance elements 1, 3, 5 have been written here. Same way B complement. B complement is U minus B. U set is 1, 2, 3, 4, 5 minus 3, 4, 5. Cancel 3, 4, 5 common elements here. 1, 2 is left out here. Now A complement union B complement. In these two, since union symbol is there, we need to combine both the values. 1 is present in both. So since repetitions are not allowed, only one time we need to write. 2, 3, 5, let it be equation 2. If you observe equation 1 and equation 2, both are same. So hence our De Morgan's second law is verified through calculation. So now let us verify the De Morgan's second law through Venn diagram. First A intersection B. In A set and B set the common element is 4, we have written here. In A set the left out element is 2. In B set the left out elements are 3 and 5. Universal set will write out of the sets where U will indicate. So 1 is the element common. Now complement Venn diagram. Other than the 4, the rest all the portion should be shaded. So this is the Venn diagram of A intersection B whole complement. Same way we need to calculate A complement Venn diagram. A complement is other than the A circle, rest of all the portion should be shaded. B complement is nothing but except the B circle, rest all should be shaded. Since it is union, we need to combine both the diagrams. We will get the Venn diagram where only intersection region will not be shaded, rest all will be shaded. Hence De Morgan's law is verified through Venn diagram and De Morgan's second law is verified from first and second equations. Therefore, De Morgan's second law is verified. So, last topic is disjoint sets and non-disjoint sets. Disjoint sets is nothing but n of A intersection B. If you don't have any common elements, then that sets are called disjoint elements. So once again, disjoint sets are nothing but if you don't have any common elements, then it is called disjoint sets and number of elements in A intersection B is 0. So when we don't have elements, we don't have any number of elements, so it is 0. So the formula is n of A union B. Number of elements of A union B is equal to add number of elements of A plus number of elements of B. Both the sides the values will be same. In case if it is non-disjoint sets means A intersection B will have common elements. So the formula will be n of A union B, nothing but number of elements present in A union B equal to n of A, number of elements of A plus number of elements of B minus n of A intersection B. So far we discussed the properties of sets. Let us start the exercise. This is the first problem. A is equal to set of LMNOPQ. B is equal to set of MNORST. We need to verify the commutative property of union and intersection. So let us start with union. A union B. This is the A set elements and this is the B set elements. You already know that union means combination of both the sets. So here which is the set is there? A set. So first complete the A set elements LMNOP Q. Then you write the balance elements of B since repetition is not allowed. Same way B union A. So first write the B set elements MNORST, then A set elements. Let it be equation 1 this is, and this is equation 2. Since both are equal, commutative property of union is verified. Same way, so now we are going to prove the intersection commutative property. A intersection B value we need to calculate. A is a set LMNOPQ, B is the set MNORST. We already know intersection means common elements. Here M is there, here is M is also there. So M we need to write. NO. So which are the common elements are M and O in A intersection B. Same way we will calculate B intersection A, we are going to get M and O. Hence A intersection B equal to B intersection A. Commutative property of intersection is verified. So now see the second problem. P is a set, A, B, C, D are the elements, Q is the set, A, E, I, O, U, R is a set, A, C, E, G. We are going to verify the associative property of union and intersection. Now let us start with union. P union Q union R. First we need to calculate which is given in the brackets P union Q. So union means combination of both the sets. So A, B, C, D, E. Since A and E already we have written here, a part of other that I, O, U. So your P union Q elements are A, B, C, D, E, I, O, U. Union R set elements are A, C, E, G. Again we need to combine these both set elements. So A, B, C, D, E, I, O, U, G. So let it be equation 1. In union repetition is not allowed. Same way P union of Q union R. First the brackets one should be solved Q union R. Q set is A, E, I, O, U and A and E already we have written here. So we are going to write C and G extra. Now P union, this one is combine all the elements A, B, C, D, E, G, I, O, U. If you count the elements of this set, they are 9 and this set is also 9. Therefore associative property of union is verified. Now let us see the case of associative property of intersection. P intersection Q intersection R. Here also we need to solve first the brackets one, P and Q. Now see in your problem, in P and Q which are the elements common. A is present here, A is also present here. E is present in Q set as well as P set. So intersection means common elements. So A comma E. Again intersection with R set A, C, E, G. Now again in these two we need to check which are the common elements. A, E and E. So final answer is A comma E. Same way P intersection Q intersection R. In Q and R also we have A and E common elements. Again we need to combine this set with P set. Again we are getting the common elements A comma E, let it be equation 2. When we compare equation 1 and 2, we got the common elements in the both the sets as A comma E and A comma E. So associative property of intersection is also verified. So now our third problem is verifying DeMorgan's law. This is the DeMorgan's first law. They gave U set, A set and B set. First you need to calculate A union B whole complement. As I said, complement is nothing but U minus A union B. U set already they have given, same thing as it is we'll write minus A union B. A and B we need to combine. So we have written 4, 8, 16, 24, 20, 28. First cancel the common elements. Common means it should present in both. 4 is there here in both, so we have cancelled. 8, 16, 20, 24, 28. So the left out element is 12. So let it be equation 1. Now A complement we need to calculate. Complement means U minus A. U set subtracted by A set. Subtraction is nothing but cancel the common elements and write the balance elements in the U set. So balance elements are 4, 12, 20, 28. So we have written here. So same way B complement. So B complement balanced elements are 8, 12, 24. So A complement intersection B complement. In these two sets we have 12 is the common element. So final answer is 12. Let it be equation 2. Compare equation 2 by equation 1. So in De Morgan's law, both equation 1 and equation 2 are equal. Therefore, your De Morgan's first law is verified. So now see the next exercise, first main, first question. N of A is number of elements in A set is 37. N of B means number of elements present in B set is 26. N of A union B is number of elements present in A union B is 51. So we need to calculate number of elements present in A intersection B. We already studied the formula disjoint sets formula. N of A union B equal to N of A plus N of B minus N of A intersection B. The values of this formula already they have given. So now in place of N of A union B, we are going to substitute the value 51. In N of A 37, N of B 26, and we need to calculate this N of A intersection B. So minus values when it comes to opposite side it will become plus. 37 plus 26 will become 63. Plus 51 when it goes to opposite side it will become minus 51. 63 minus 51 is 12. Therefore, N of A intersection B value is 12. So here we have total number of persons as 50. N of T is number of people drinks tea is 30. N of C number of people drinks coffee is 25. N of T intersection C number of persons will drink both is 16. We need to calculate either tea or coffee. Second one is neither tea nor coffee. So either tea or coffee is nothing but union value we need to calculate. So according to disjoint sets formula, N of T union C equal to N of T plus N of C minus N of T intersection C. N of T value is 30, N of C value is 25, N of T intersection C value is 16. 30 plus 25 is 55, 55 minus 16 is 39. Let us see this one through Venn diagram. Now let us see this 39 how to represent in the Venn diagram. First of all, T and C how many people are drinking? 16. So you need to enter 16 value in the intersection region, and only T how many are drinking means N of T they gave 30, subtract 30 out of 16. So 30 minus 16 is 14. Same way coffee 25 are drinking, among them only coffee how many are drinking? 25 minus 16 9. When you add all these three 14 plus 16 plus 9 we are getting 39. So either tea or coffee how many persons are drinking is 39. Now second one we need to calculate neither tea nor coffee. How many people are there? There 50. So 50 minus either tea or coffee is drinking by 39 persons. So 50 minus 39 11. So 11 people will not drink neither tea nor coffee. In a survey of 150 people, the observed number of people are having eye problem is 90, number of people having heart problem is 50, and both eye and heart problems are 30. We need to calculate how many are having either eye or heart problem. So according to the disjoint sets property, N of E union H is equal to N of E plus N of H minus N of E intersection H. N of E value is 90, N of H value is 50, N of E intersection H is 30. 90 plus 50 is 140, 140 minus 30 is 110. Now let us check whether this value we will get through Venn diagram. Now see, here we have two sets, E for eye, H for heart. Both of the problems having number of people is 30. So we need to write it in the intersection region. Eye problem they give 90, but how many are having only eye problem? 90 minus 30 is 60. Same way hard problem is given by 50. Only hard problem how many are having? 50 minus 30 is 20. Add all this, we are getting 110. So our calculation for either I or odd problem is same. Now they have asked the question percentage of people either I union heart. So we got total people are 150 and we got the value either heart or I problem is 110. So 110 by 150 into 100. Why 100 we are multiplying? Because we need to calculate percentage. 0 0 will get cancelled. 11 into 100 is 1100 divided by 15 we will get 73.33%. So let us take total number of farmers in a village is 120. Number of farmers will grow vegetables 93, flowers 63, sugarcane 45. Vegetables and flowers 45, flowers and sugarcane 24, sugarcane and vegetables are 20. Now we need to calculate how many will grow all the three. So formula of how many will grow all the three is total farmers are 120 minus n of v plus n of s f plus n of s, all the three we need to add and subtract it from n of v intersection f, f intersection s, v intersection s. So 93 plus 63 plus 45 is 201, 45 plus 24 plus 27 is 96. When you subtract these two you are getting 105. 120 minus 105 is 15. So let us represent this given data through Venn diagram. We got 15 farmers, so write 15 farmers in the intersection region. Now V intersection F is 45. Already 15 are there here, so 30 will be the balance. 30 plus 15, 45 we will get. Same way F intersection S. F intersection already 15 are here, so 24 minus 15 is 9. Add these two, you are getting 15 plus 9, 24. V intersection S. We have 27 they have given, 15 is already entered here, so 12. 12 plus 15, 27. If you want to know how many grow only vegetables, add all the three, subtract it from 93. 30 plus 15, 45, 45 plus 12, 57. So 93 minus 57 is 36. Same way for sugarcane also, 12 plus 15, 27, 27 plus 9, 36. So 36, 45 minus 36 is 9. Same way for flowers, 30 plus 15, 45, 45 plus 9, 50, 54. So 63 minus 54 is 9. So this is the way how to represent the total number of farmers grown all the three. This is 120 is the total farmers, 105 we have calculated, 120 minus 105 is 15 farmers are growing all the three vegetables, flowers and sugarcane. So now recapitulation, what and all you have studied in the sets chapter. First one is commutative, A union B equal to B union A, which is in union, A intersection B equal to B intersection A in intersection. Next, associative property, union and intersection. Distributive property, union over intersection, intersection over union. And DEMORGAN'S laws, first law and second law. Now last one is disjoint sets formula, n of A union B equal to n of A plus n of B minus n of A intersection B.